Alright, good morning. Okay, today I would like to share about a semiconductor device that we call as MOSFET. Okay, maybe some of us has even heard about this semiconductor. Okay, so today I will explain more and further about this semiconductor. Okay, so let's move to the introduction of MOSFET. Okay, so what is actually MOSFET? Okay, MOSFET is metal oxide semiconductor field effect transistor. Or the short name, we call it as MOSFET. Okay, it is a semiconductor transistor. Okay, so this MOSFET has three terminals. Okay, first the source. Okay, second drain, and third is gate. Okay, so this MOSFET is a semiconductor device that is widely used for switching purpose and also for the application of electronic signals in electronic device. Okay, so this is a general introduction of MOSFET. Okay, so let's go to the types of MOSFET. Okay, actually MOSFET have two types. Okay, first is the depletion mode, or we call it D-MOSFET. Okay, second is the enhancement mode, or we call it the E-MOSFET. Okay, so what is the difference between this D-MOSFET and the E-MOSFET? E-MOSFET. Okay, so first of all, for the depletion mode, okay, when there is zero voltage, no voltage on the gate terminal, so the channel shows its maximum conductance. Okay, as the voltage on the gate is negative or positive, then decrease the channel conductivity. Okay, this is the depletion mode. Okay, so how about the enhancement mode? Okay, it is actually like vice versa of this depletion mode. Okay, when there is no voltage, zero voltage on the gate terminal, the device does not conduct. Okay, so when more voltage applied on the gate terminal, the device has good conductivity. Okay, so this is the difference between the D-MOSFET or the depletion mode MOSFET and the enhancement MOSFET, or we call it E-MOSFET. Okay, so we move to the next point, which is how does the MOSFET work? Okay, what is the operation? What is the work principle of this MOSFET? Okay, so generally, how this MOSFET work? Okay, this MOSFET has the N terminal, okay, two N terminal and the substrate. Okay, so like I said earlier, okay, this MOSFET has three terminal. Okay, first is the source, second is the drain, and third is the gate. Okay, so to make the MOSFET work, okay, we have to connect this MOSFET with any battery, with any source like battery. Okay, so we have to connect the source terminal to the negative terminal of the battery, and the drain terminal to the positive terminal of the battery. Okay, so when we connect both terminal, okay, what will actually happen? Okay, when we connect both terminal, okay, there is nothing happen, and because of what? Okay, because of when the drain connect with the positive terminal, the reverse bias will be occur. Okay, the reverse bias will be occur, and when the source is connected to the negative terminal, the forward bias occur. Okay, for this connection. Okay, so when forward bias meet with the reverse bias, okay, so no current will be flow. Okay, so nothing will happen. Okay, when we connect like this. Okay, so what we have to do? we have to connect this connection with one more battery. Okay, so when we connect with one more battery, we will the source will be connected to the positive terminal of the second battery. Okay, and then the negative terminal follow to connected with the negative terminal of the first battery. Okay, so when we connect like this, okay, when the positive terminal connect with the source of the MOSFET, okay, no, we are not connect the positive terminal with the source, but we connect the positive terminal of the second battery with the gate. Okay, so when we connect the positive terminal with the gate, okay, so the electron between the N terminal, okay, that connected to the source and to the drain, okay, the electron will come close to the gate terminal. Okay, so it like make a junction, okay, at the gate terminal, okay, between the source and the drain. So what will happen? Okay, the current can flow. The current can flow, okay, when we connect the gate with the positive terminal of the second battery. Okay, so the voltage that we applied, we call it as a threshold voltage, okay, or the minimum voltage, okay, to activate the MOSFET, okay, or to allow the current, okay, to flow through the circuit. So this is how the basic principle or how this MOSFET work. Okay. Alright. So now we move to the application of the MOSFET. Okay, there are several application of MOSFET. The most one is the switch. Okay, MOSFET used as a switch. Okay, so how MOSFET could be used as a switch? Okay, like just I explained about the work principle of the MOSFET. Okay, so when the current connected to the gate terminal, okay, so the MOSFET will act as a wait, okay, before there is when there is no current, okay, connected to the gate terminal, okay, so there is no current can flow in the circuit, so the MOSFET will act as an open switch. Okay, so no current could be flow, okay, could flow along to the circuit. Okay, so when we connect the positive terminal, okay, to the gate, okay, so the current could flow and the MOSFET will act as a closed circuit. Okay, so it will allow the current to flow through the circuit. So this is how MOSFET act as a switch. Okay, so this is one of the application of the MOSFET. Okay, there is other application of MOSFET such as in auto intensity control of street light using MOSFET. Okay, so MOSFET will allow the intensity, will control the intensity of the street light. Okay, the working principle is same as the switch and as the other application. So this is how it control the intensity of the street light. Okay, next we go to the comparison of BJT, FET and MOSFET. Okay, so what is the difference between these three transistors? Okay, Okay, so we will compare in terms of several component. Okay, first of all the structure. Okay, so for the BJT or bipolar junction transistor, okay, it has three terminal. First of all the collector, second is emitter, third is base. Okay, for the FET, field effect transistor, and the MOSFET, okay, it is actually have the same structure, which is have drain, source, and gate, because MOSFET is one of the type of FET. Okay, so FET have two types. One of it is MOSFET. Okay, because of that, it has the same structure as FET. Okay, so next we move to the current gain. Okay, so current gain is given by the BJT. Current gain is given by the current that is applied to the base. Okay, so base okay, so current will flow from collector to emitter. Okay, but the base will control the current, okay, that is applied, okay, to the from collector to the emitter. Okay, that is called I said, okay, current gain is given by the current that is applied to the base. Okay, so for FET and MOSFET, okay, it has the same things, because the current gain is controlled by the voltage that is applied to the gate. Okay, so the voltage applied will give the output current. Okay, different with BJT. For BJT, the current applied, okay, that will cause the current output. Okay, but for FET and the MOSFET, the voltage applied, okay, that will determine the current output. Okay, next for high power switching transistor. Okay, for BJT, it is a high voltage and low current device. Okay, the current is limited to a few ampere, but could operate to even thousands of volts. This is for BJT. For FET and MOSFET, it has the same high power switching transistor, which is there are high current and low voltage devices. Okay, because the resistance between the drain and the source is low. Okay, so it could produce the high current output. Okay, so there is several application of BJT. Okay, like audio amps. Okay, one phase load controls. Okay, and stepper motors. Okay, for FET and MOSFET, okay, same. There is several application, like I said earlier, the switch, okay, the power management, the welders, and the inverters. Okay, next we go to the parameters and components. For BJT, we have to look for several parameters, okay, like the continuous current rating, the current gain, the background voltage, the on voltage value, and the turn off time. Okay, for FET and MOSFET, okay, the component, the parameter that we have to look is like the threshold voltage. Okay, means the minimum voltage to activate the device. Okay, and then the continuous current rating and the on resistance. Okay, last but not least, okay, the price. Maybe I could explain about the price. Okay, for BJT, it have the lowest or the cheapest price, okay, compared to the FET and the MOSFET, which have the a bit expensive, okay, more compared to the BJT. Okay, so that are the several different or comparison of BJT, FET, and the MOSFET. Okay, so the conclusion of this presentation is more about the MOSFET, okay, which is this MOSFET is actually very useful for us, okay, to use it in our daily life, okay, as a switch, okay, as a power intensity supply, okay, but we have to determine all of the device has their own characteristic, okay. So when we want to make something, or we want to use this device, we have to determine, okay, how about what is the input that we want to supply, what output we want to get, okay, how about the resistance, okay. So from this we could determine, okay, which device that we want to use, okay, either BJT or MOSFET, okay, for our maybe innovation of something that we want to do, okay. So this is all about especially the MOSFET that I want to present today, okay. So thanks for hearing. Hope this is very benefits for you guys, okay, to know more about MOSFET, okay. So thanks again, okay. This is some reference for the presentation that I just said just now, okay. So thanks again, goodbye, okay. See you next, maybe in the next video, okay, goodbye.